the illustration is of, so here we are performing this illustration or an example in order to prove the onto function. Under this illustration, we are assuming a function that is from R to R, real to real, which is defined by means of the function that is f of x is equals to 2x plus 3. So here we have to prove f of a, that is the image of a must be in equals to b. So here the given function is of f of x is equals to 2x plus 3, which is the given function. But here we are going to assume, so here let f of x be y. So here we are going to assume this f of x, the given function f of x, as y. Let y is equals to f of x, then that is equals to 2x plus 3. Then now instead of f of x we can replace by means of y. Then now that implies, so here y is equals to this right hand side, that is 2x plus 3. Here I have replaced f of x, instead of f of x I replaced by means of y. Then now, so I am interchanging right hand side and left hand side. So that implies 2x plus 3 totally right hand side I wrote on the left hand side, then that is equals to total left hand side I am going to write on the right hand side. So I got this step. So here by interchanging LHS, that is left hand side and as well as right hand side at a time. So therefore there won't be any sort of changes in their signs of the terms. Then now, so here the next logical step will be of, that implies 2x when plus 3 is transposed over to the right hand side. So we will be getting the step as, so here that is equals to right hand side value is of y, then now plus 3 when it is transposed over to the right hand side, so it will be of minus 3. So I got this logical step. So here by transposing, that is LHS term, which is nothing but plus 3 over to RHS. So by transposing this term over to RHS, so here plus 3 became minus 3. Then now here I want to find out x. So instead of, in order to make the x as the subject, so I have to divide both sides by means of 2. So here the next logical step will be of, that implies 2x overall divided by 2 is equals to y minus 3 overall divided by 2. So here I got this logical step by dividing both the sides by means of 2. So here dividing both the sides by means of 2. Then the next logical step will be of, so here 2 and 2 gets cancelled by means of 1 in the denominator and 1 in the numerator. So here there is of only x. So that implies x is equals to y minus 3. Then the next logical step will be of x is equals to y minus 3 overall divided by 2. So here let us substitute, but the given function is of f of x is equals to 2x plus 3 is the given function. So let us substitute x as y minus 3 overall divided by 2. So here at x is equals to y minus 3 overall divided by 2, when this value is substituted in the place of x in the given function, that is f of x, then now that implies the next logical step will be of 2 into, instead of x, so we have to substitute y minus 3 overall divided by 2. Then now this plus 3 must be copied as it is. Then the denominator 2 and the numerator 2 will be gets cancels by means of 1 in the denominator and 1 in the numerator, because there is of into symbol in between. The next logical step will be of, so that implies, so 1 into this bracket is of the same bracket, that is y minus 3, and this plus 3 must be copied as it is. So here this 3 is of positive and this 3 is of negative, so both will be gets cancels. So here that implies y. So in this manner we got f of x. So therefore f of x is equals to y. So here f of x equals to y, hence we can write it as f of a is equals to b. So here the image of a is equals to the b. So here therefore it is said to be called as an onto function. So here therefore the given function that is f of x is equals to 2x plus 3 the given function is an onto function, or in other words called as the surjection. And the third one which is left over is of bijection. A bijection is a function which is one to one and as well as an onto. So here when a function is one to one and as well as onto, then only it is said to be called as the bijection. The third one is of bijection, or in other words one to one onto function. So here the definition of this bijection is of a function, when we suppose a function that is f from a into b is said to be bijection if and only if the given function f, which is from a into b, is one to one and also onto, that is onto function. So here it must be of one to one and as well as onto, then only is said to be called as a bijection. Then now here one illustration under this. So here illustration is of if function f is equals to set consisting the ordered pairs such as x comma a comma y comma b comma z comma c. So here there are of three ordered pairs in this relation, that is yes, first ordered pair is of x comma a, the second ordered pair is of y comma b, and the third ordered pair is of z comma c. So here to be a one to one function, so no two different elements of a must have the same image in b. So here x and y, they are having different images, and y and z, these are the first two elements, they are having different elements, that is b and c. Similarly xa and as well as zc, so x and z, so are having different elements such as a and c. So here no two elements of a, that is x y z, are belonging to the set a, and a b c are belonging to the set b. So here no two elements of set a is having the same image in case of b. So therefore it is said to be called as a onto one function. Since no two elements of set 1 is having the same image in set 2, that is set B, hence f equals to x comma a, set consisting x comma a, y comma b, z comma c is one to one function. So similarly let us see. So here the given function is of f is equals to x comma a, y comma b, z comma c. So here f of a equals to b. When f of a is equals to b, then only say it is said to be called as an onto function. So here image of x is of a in the first set, that is first ordered pair, then the image of y is of b, which belongs to the second set. So here image of z, which belongs to the first set, is of c, which belongs to the second set. So here since f of x is equals to a in the first set, then f of y is equals to b, that is the second set, then f of z is equals to c, which is the image of f of z is the image of what I say here c. So its image is of c. Therefore since f of a is equals to b, therefore f the function given function consisting the ordered pairs of x plus x comma a, y comma b, then z comma c. So here is onto function. The given function is of both one to one and as well as onto, then the given function is said to be called as the bijection. So here the next logical step will be of since the given function that is f is equals to set consisting the ordered pairs x comma a, y comma b and z comma c is 1 to 1 and also an onto functions, hence the given function is said to be a bijection.